In example 2, we're finding an equation for the inverse of the following relations. And if you'll remember in example 1, all we did for the coordinates for those points, we just switched the x and y. And it's really simple and similar whenever we are finding an equation for the inverse, because all we do is we switch x and y. So wherever there is a y, I'm going to put an x there in my equation. And wherever there was an x in the original, then I'm going to put a y. And then the minus 4 just stays the same. So x equals 2y minus 4 is the inverse. For part B, again, wherever there's an x in the original, put a y. Wherever there's a y in the original, put an x. So it would be y equals y times x squared minus 1. And then C would be y cubed x equals 7. Now, example 3, our original, would be graph y equals 3x plus 1. That's what we're starting off with. So we see that our y-intercept is 1. So I go to 1 on the y-axis. And then our slope is 3. So I go up 3 units, 1, 2, 3, and over 1 to the right. And that's where I'll put my line. So we've done the first part. We've graphed y equals 3x plus 1. So now we need to find the equation of the inverse. So if we started off with y equals 3x plus 1, all we do is change our origin. In the original, we change our y's to an x, and if there was an x in the original, we change it to a y. So it would be x equals 3y plus 1. So that's the equation for the inverse. In order to graph this, I'm going to use an xy chart. I'm going to choose some y's that and see what I get for x value, and then I'll just plot that point. So let's say I have a y value of 0. If I plug 0 in for y right here, that would be 3 times 0 plus 1. So whenever y is 0, x is 1. And then let's say that we make y 1. Okay, so if I plug 1 in for y, I get 3 times 1, which is 3, and 3 plus 1, which is 4. So x would equal 4. And now I can plot these 2 points of 1, 0 and 4, 1. So we've gotten every part except 1 done for this example. We've graphed our original. We then found the inverse of that you can see our work there in red. And then we graph the inverse, and we have one thing left to do, and I'm going to do it in green, and that would be to graph the line y equals x. And this line, if you think of the y equals form, y equals mx plus b, the b is your intercept, and the m is your slope. See, what's really great about this example is I showed you when we graphed y equals 3x plus 1, I showed you how to graph it using the slope and the y-intercept. And then when we graphed x equals 3y plus 1, that wasn't in y equals form, so I just did an xy chart for that. So that was two different ways to graph a line that I showed you. Now, for y equals x, that's in y equals form, but notice that we don't have plus a number, plus anything. So that's like saying plus 0. That means that our y-intercept is at the origin. So our y-intercept is 0. We cross the y-axis at 0. And then our slope is 1. So from that point of 0, I go up 1 and over 1 to the right, and I put me a point there. and then my graph of y equals x will be in green. So now that we have our graph of y equals x there in green, we can clearly see that our inverse function or inverse equation of x equals 3y plus 1 is a reflection of y equals 3x plus 1 over the line y equals x.